Hey everyone, welcome to AC Academy, and today we are going to review Algebra 1, Section 1.3.2, Slope, solve for slope from tables and plots. Okay, so let's step into it here. Question number 1 is, what is the rate of change of y with respect to x for this function, rather this table, right? So we have this table, and it's asking for the rate of change of y with respect to x for this function. So what does that sound like? That is asking for the rate of change, so that's delta y, with respect to x, so delta x, right? And that's going to be m, which is ultimately our slope, right? So it's asking for the slope of this function. And actually, just to extend the question, let's go ahead and solve for the entire function. Let's see if it's possible. Right, so that is saying that we want to put this in a standard format, y equals mx plus b, given this table here. So first thing, we need to solve for, let's solve for b first. Solve for b, or rather lowercase b. Okay, so how do we solve for b, which is the y-intercept? We get our y-intercept whenever x equals 0, right? So this would mean x equals 0 here. Looking at this table, do we have a value where x equals 0? Yes, we do, right here. And what is y whenever x equals 0? Y equals 3 whenever x equals 0. Okay, so that is going to be our y-intercept. So whatever the equation is, you don't even need your equation yet. We have y equals m. We don't know m yet. X plus b. We know x equals 0. Looking at this plot, we know x equals 0. So we know m right here is going to be 0. And we know y equals 3. So 3 equals m times 0 plus b. Therefore, we know that b equals 3. Now let's solve for m. And reiterating real quick, I know I may have blasted through that, but what I did, I have this standard format here. I'm asking to solve for the entire equation. So we reference our plot here. What can we solve for? Well, using the standard format, we have two unknown variables, right? We have a table with given x values and given y values. We don't know m, and we don't know b. So we got to solve for two variables, and we have multiple points to solve for these two variables. So first thing I did was plug in x equals 0 to get rid of m, right? Because 0 times this, whatever constant m is going to go away because it's multiplied by 0. And then we have a y value for whatever value it is whenever x equals 0, which we have y equals 3. Okay. Second, let's solve for m, right? So we have this table again. We're looking for the slope, so we're looking for m equals delta y over delta x. Okay. So normally you would check all of these points. You would check what is delta y, what is delta x, so on and so forth. Now, one thing about this table is not evenly distributed. So one mistake someone would make here, let's draw this out and let's make the mistake so you see what not to do. We have -2, 0, 3, and 7, right? So, we have 12, 3, -10.5, and -28.5. So we see the rate of change. Again, we're looking for delta y over delta x for each step. So we have -2 to 0, that the delta x there, let's say 2, right? Here it's 3. Here it's 4. Right here, 12 to 3 is 9. 3 to 10.5, a -10.5, sorry, is 13.5. And then 10 to 28.5 is 18, right? Okay, so what what one would do they'd look at these numbers and be like, wait, or rather they'd only do one set. Or they'd look at these numbers and then they'd be like, well, this is changing and this is changing. I don't know. I'll just like average the value or something like that, right? So that's not what you particularly want to do. I always recommend, drawing a plot so you know kind of what this looks like, you know what your slope is, and then going based off of 2 points that extend the whole range of the plots. Right, so let's plot this really fast, and it can be a rough plot. You don't have to put tallies or anything. We have -2, 12, which is like about here, 0, 3, 3, -10.5, and 7, -28.5. So your plot's going to go like this, with this being positive x and this being positive y. And we notice we have a negative slope here, right? So let's pick 2 points on this plot, the same 2 points. So we have to make sure that these two or like these two or something like that, right? So delta x. So let's do these first 2 points just because it's pretty straightforward. So delta x over delta y is going to be let's do these 2 points. I think that's a bit more challenging. So we have 7 minus 3 over -28.5 minus -10.5, right? Which that negative turns into a positive. Put this into your calculator really fast. We have 4 up top. And then -28.5, -28.5 minus -10.5 equals -18, right? Which I just did over there. Okay, so 4 divided by -18 will give you -2 over 9. -2 over 9. That's what m's going to equal. So writing out our final equation here, which I've run out of room. But y equals m, -2 over 9, x, b equals 3 here, plus 3. And that is the equation. Okay? Again, if you have questions over that, go ahead and put it in the comment section, and I will get to you on that. Now let's look at this problem. I'm going to zoom in a bit, and we might be doing a little bit rough approximation here since there aren't exact values and we don't have graph paper and so on and so forth, but you will get the idea of the problem. Question 2 states, what is the rate of change in the volume of gas with respect to temperature? Right, rate of change, the volume of gas, which is on the y-axis, so delta y, with respect to temperature on the x-axis, delta x. So it's asking for the slope again. M equals delta y over delta x. So what you want to do, you have this plot, this guy is asking you for the slope. You see that it's linear, and we're making, for this section, all of the plots and everything is going to be linear. So same assumption in the problem above. We're going to have 2 points here. So we could do like 20. Let's do this point. Just even numbers that are on a line or very close to a line. So these 2 points. Okay, so let's put this on a table. X, Y. We have 0.1, and X being temperature, Y being volume of gas. We have 20 degrees Celsius, and then we have 80 degrees Celsius. There. Now this goes by 1, 2, 3, 4, 5. So each line is 1. Since 20 is right here, 25 is right here, and then you have 24, 23, 22, 21, 20, right? So this would be 23 milliliters, and the next one would be 25, 26, 27, 28. 28 milliliters, right? Degrees C. So we're using the same thing, delta y over delta x, which would be 28 minus 23 milliliters over 80 minus 20, right? So we're going to put that in, 28 minus 20, 35, and then 80 minus 20, 60. Right, so 5 divided by 60 simplifies to, 5 over 60, 1 over 12, right? And boom, okay. That is the rate of change, right? If you want to solve for a full equation, you look for the y, put this in blue, sorry, y equals mx plus b. We just solved for m. Now looking at this plot, what is b? The y-intercept when x equals 0, we look, it's 22, right? And that's just straight looking from the plot. So our full equation, changing colors again, y equals m, which is 1 over 12, x plus 22. Okay, hopefully that makes sense. If you have any questions over any of this, feel free to go ahead and comment or send me an email about any problems or any personal questions over whatever homework or whatever subject you're looking at that you may have, and then I will get to those as fast as I can. Anyway, thanks for watching, and I'll see you in the next video.